Now let's get into real action. Try to build the algorithm for deleting the minimum element from the min heap. So we have the data posted in the array, and this is the last element in that. So whenever we delete, we know that the first element has to be copied onto that. So before that, out the first element. So this can be made useful for some other, for whatever purpose this whole heap was built. So let that be sent out. Second thing is copy the last element into the first element. That means the last element 12 comes here, and the next thing is change the position of last. So now onwards, call this last. Done. So that's initiation required, and once this is done, the next thing we need to see is this in right place? Of course not, because this has come from bottom directly onto the top. Therefore, it's definitely not in the right place. So it has to be moved to the right place. So in doing so, one thing we need to make sure is the minimum of all the elements left has to come to the position 1. So that can be done easily by verifying whether position 2 is smaller or position 3 is smaller. So whichever is smaller, we need to swap it. So what is the next step to do is let me start I equal to 1, and then look for position 2, that is a of 2i is less than a of 2i plus 1. If a of I is a of 2i is less than a of 2i plus 1, so that means we need to work with a of 2i. So what we should do, a of 2i and a of I need to be swapped. So 12 and 3 are swapped. Once that is done, what's next thing? Now 12 has shifted to position 3, and therefore position 3 has to be updated. From position 3 onwards, updation has to take place. Therefore, I is changed to 2i. This is if the condition is true. Otherwise, this has to be replaced with swap between a of I and a of 2i plus 1. So that means between 1 and 3, swapping has to be done. If that is done, then make sure to update this to the new one. Now what has happened? If you just look at this part, I is equal to 1, then 2i is 2. So a of 2i is having a value of how much? 3. And a of 2i plus 1 has a value of 5. Therefore, this condition is true. So we swap these two. So there was a 12 here and 3, and 12 and 3 get swapped. So 3 comes here, 12 comes here. Right. So that one work is over. What next? Then children of 2 have to be verified. So children of the 2 have to be verified. What is that? Then this whole thing has to be repeated as long as what? A of I is greater than A of 2I, or A of I is greater than A of 2I plus 1. So as long as this value is greater than any one of them, then this should continue. So that's it. So what happens next is I value, which was 1 in the beginning, now it has become 2. So 2I will be 4 and 2I plus 1 will be 5. So we back into this. So 12 is greater than 11, 12 is greater than 7, definitely. Therefore, this whole thing continues. Now we are checking whether A of 2I is less than 2I plus 1. A of 2I less than 2I plus 1, definitely no. That means this condition is done. So A of I and 2 of I plus 1 are swapped. Therefore, 12 gets swapped with 7. 7 comes here, 12 comes here, and once that is done, then 2I plus 1 is now called I. This was 2I plus 1, now this will be called I. So what is that? The next value is 2I, that is 10, and that's the last element. Of course we have, and 10 plus 1, 11 does not exist. We need to check for that. Okay. So once that is done, then we can make sure to put all infinites to begin with. That will solve our problem. Okay. Then what happens is 5, 2 times 5 is 10. So this is y. This is 2I plus 1. 2I value is 8 and I value is 12. So A of I is greater than A of 2I. Yes, of course. Therefore, it gets into the loop. And then A of 2I less than A of 2I plus 1. Yes, of course. This is 8. This is infinity. So this is a swap between A of I and A of I plus 1. So 8 comes here and 12 comes here. So in all, what all changes are done? This has gone. Then 3 has changed its place, 7 has changed its place, 8 has changed its place, and this is no more remaining. So what has happened? 3 has come here, 7 has come here, then 8 has come at 5th place, and 12 has come at 10th place, and after that you don't have anything. So that's how the logic is built. So I'm just giving idea how the things are done. Not much details about the syntax and all are worried. I'm just only worried to convey the logic, how to build the logic. So that's the logic. So that's the initiation, and that's the while loop we have, and that keeps moving it down and down and down till you reach the root. Once you reach the root, that's the end of it. So that's how a minimum element is deleted from the min heap. A whole logic exactly fits when you talk about max heap. Then the whole system will be different. On the root, you will have maximum of all the values. The same condition follows. Only things is less than will become greater than will become less than, because min and max the opposite way you are working on that. That's one way. Other way, all this whole thing, if you want to make it a max heap, then you read all the numbers with the negation. So in this case, 3 is the smallest element, therefore this is a min heap. And if you negate all the data, then -3, -7, -5, -11, -8, -9, -6, -14, -16, -12 and all that. In that case, -3 happens to be the largest element. So automatically this same system behaves like a max heap. So min and max, they're just a sign is the difference. So if you have a min heap algorithms with you, and if you wanted to work for max heap, just make sure to use min heap, but before that change the signs, use min heap, and the results you present after changing sign again. So that's as simple as that. So that's something about heap. That's a priority queue. Thank you. Keep watching. Many more issues to be discussed in future. So please keep watching. Thank you.